this section, we have been talking about exponents so far, and I want to introduce new ideas today. I want to talk about the fact that with exponents, well, let's just actually do a quick little bit of revision. So what have we learned so far in exponents in this section? We've learned three main laws. We've learned the law that talks about when we multiply things that have the same base, we simply add powers. We also spoke about the situation when we have powers to the same powers like this, and then we multiply, so we get 2 to the 12. And then we've also spoken about the situation where we're dividing. Guys, is someone still who's not on mute? If I can ask you to mute everyone for now, just so that we can have
Sir, you said.
Mr. S, can you? Oh, good.
Yeah. Okay. Can you hear me? Oh, fantastic. So that's and stuff. Now, in the previous lesson, we've never discussed what happens when we have something to the power of 0. Okay, something to the power of 0. Now, does anybody know what happens just from knowledge of classes? If we have something to the power of 0, what is that always going to be equal to? Let me show you why that is. Divided by 2 to the 3. Would you guys all agree that anything divided by itself is 1? Okay, because anything over itself is 1. Now, we have powers, and we have the same base. What we then have is 3 minus 3 is 0. And so we will then see that. So the fact that anything is to the power of 0 is 1 is simply because of this relationship. Like, this process could be repeated. So I could have something like 3 to the 2 over 3 to the 2. If we use the law of exponents, if the bases of the same, what we do, we subtract the powers. And so we have, could I ask you, Boikanyo, could you turn yourself on a mute? And Offense, if you could also put on mute, I think there's just a bit. Okay, so this would be to the power of 0, but you also know 3 squared is the same as 9, and so 9 over 9 is just 1. And so that's my explanation why anything to the power of 0 will just be 1. So let's look at some examples here. If I say y to the power of 0, I know straight away that's going to be 1. If I have 6 to the power of 0, that's going to be 1. In fact, if I have all of these things, doesn't matter what they are, if it's to the power of 0, it's going to be 1. Okay, so that's the first new idea I want us to talk about. So very quickly, could you guys do A, B, and C for me and pop that in the chat? So I want you to do the first 3 and just pop it in the chat. And then if I look at your answers, then I'll be able to tell if you've understood that first bit.
Mr. S, we have a question from Tanya.
Tanya, go ahead, Tanya.
Tanya, you can ask your question. Okay, not reaching her. There is a question from, well, there's no name, but it says iPhone 2.
Okay, so I see the answers are coming through in the chat. For A, it's 1. I agree with you guys.
Mr. S, we have a question from Mamelo.
Momelo, go ahead.
Sir, I'm asking, can you please explain again?
So all that we're checking, I'm going to now. Basically, when we deal with exponents, the first bit of the lesson is just showing you that anything to the power of 0 will be 1, as long as there's only one thing. So if I even make something like this, 2xy, if it's to the power of 0, it will equal 1. And that comes as a result of what I was explaining earlier on, that we can use earlier laws. There was an earlier law that said, if you're dividing two numbers and they have the same base, all you need to do is write down that same base and subtract the powers. And 2 minus 2 is 0. And then we know that anything over itself is 1. So we're using that idea, but you don't need to understand that perfectly. The main concept in this first exercise was just to practice anything to the power of 0 is 1. Now, the second round of questions is a little bit tougher. So I want to see, can you get answers for D, E, and F? So I'm going to let everyone try those. Now, notice there's subtle differences here, but let's just see how it goes.
Mr. S, there's a question from someone, it says iPhone 2.
Okay, go ahead. You can unmute yourself if Lebo has said that you're going to ask a question.
Nothing there.
Okay, it's fine. It might be pushing the wrong button by mistake. Okay, now I see for D, some people are saying it's 1, but I want to point out to be careful here because the power of 0 is only referring to the y over there. Whereas the power of 0 over here is referring to everything inside the brackets. And in this third one, the power of 0 is only referring to the thing inside the bracket. And so I want you to think, how will that affect? Because remember, if something's next door to something, it means it's being multiplied. So see if that affects your answer or not. So in D, y to the power of 0 is in fact 1, but then you still have the 2 in front. So 2 times 1 gives you 2. And so the answer for D would be 2. Let's wait a little bit more for answers for E and F. I'm not seeing a lot of answers for E yet. I'd like a few more. So one of the other things, especially if you're new, we love to use the chat to show our answers. I'm not too worried if you're correct or not at this stage. I mainly just want to see you committing to something. Yeah, in question E, the answer is going to be 1 because the whole thing is to the power of 0. Now, what is F going to be? So the 4x in front doesn't really get affected. So you know that over here, I use a dot to show multiplication. This whole thing is going to be 1, but anything times 1 just stays the same. And so F would be 4x. Okay, so it's not going to be, if you thought the x was a multiplication, then I can see why you would be a little bit confused there. I'm going to make up 3 more. So D, E, F, we got A, B, C, D, E, F, so G, H, I. Let me make up 3 more questions because I feel like we're not quite done with this yet. So I want to know, what do you get for G? And then I want to know, what do you get? Let's make this for that one. And then, well, let's just do those two. So what do you get for G and what do you get for H? So again, notice how in G, the power of 0 is only referring, so I suppose I've jumped to variables here, so I must be careful. The power of 0 is only referring to the thing inside the bracket. I suppose I could have put numbers inside too, but so G's answer is just going to be this whole thing to the power of 0 is 1. So the answer for G will just be 2. What's the answer for H going to be?
Mr. S, Tato
Yeah.
says he doesn't understand E, if you don't mind quickly explaining that.
So E, this whole thing inside the bracket, even though it looks very fancy, is just to the power of 0, and anything to the power of 0 is going to be 1. And so that's why, because the whole thing is included in the bracket, I'm not really worried about how fancy it is inside. I just, it's going to be 1. The same idea is going to apply in H. This whole thing in green is to the power of 0, and so it's 1, and there's a 4 at the bottom, and so my final answer is just going to be a quarter, or 1/4. Okay. Now, guys, we're gonna do a main exercise tonight, which includes this, and so I'm going to come back to it later in the lesson. So if you're unsure, don't worry, more questions are coming. I just want to discuss one other thing, which is called the negative exponents with you. So those of you who are putting 4, just be aware the 1 is on top, the 4 is on the bottom, and so it should be 1/4 is your answer. Okay, so I want to discuss one other situation here. Now, so in case you're worried that I'm going too fast today, we're going to start proper practicing after I've discussed these new 2 things. These are just the starter parts. What happens in situations like this is what I want to talk about. So, and I'd like to ask you, what is different, or what is
Mr. S,
different?
your connection seems to be a bit unstable.
Does it? Okay, can you hear me now?
Yes. Yes,
Okay.
I can hear you.
Okay. I want to ask the students, what is difficult or different about what's currently on the board? I'd like them to type in the chat.
Is this grade 8?
It is grade 8, yeah.
Oh, okay, thank you.
All right. So what is different or what is difficult about what's currently on the board? And I'd like you to type it in the chat, please.
Mr. S, we have a question from iPhone 2.
I think for now, let's just pause on the questions. I want to rather have people answer in the chat.
Okay.
So if we look at, I want to know what is different or what's different. It's in fractional form, yes. The main thing I want to point out is that the top power is smaller than the bottom power. Can you see that? Up until now, we've avoided this type of situation. And what I want to tell you is that the law for dividing exponents still applies here. And what we're going to do is we're going to get, the base is still going to be 2, but what's 3 minus 7? We get minus 4. Now, this is quite a strange new thing. So I just want to pause for a minute and show you this. I'm dividing 2 numbers that are in exponential form. I've checked that the bases are the same. The bases in both cases are 2. So I write down that same base. And now, just as I did before, I'm subtracting the powers, but I've ended up with a negative power. Okay, so have a look at that for a second. Now, I want to point out something else. If I had written this the long way, when we started this section, I was making you all bored because I was writing out what it means to have a power. So at the very beginning of the section, we said 2 to the power of 7 literally means 2 times 2 times 2, 7 times. So I've written this out here 7 times. Now, if I'm dividing in this way, what we normally would have done, guys, someone's on, if I could ask you to put yourselves on mute, please. Levels, I can often monitor the students and just to suggest to those who aren't on mute to mute themselves. I can't see everyone, but quite a lot of feedback coming through.
Mr. S, can you please unmute yourself?
I can indeed. Cool. All right. So back to this. If you look at it doing it this way, what we would have done is we would have said 2 over 2 is 1, 2 over 2 is 1 here, and 2 over 2 is 1. And what you'll see is that all we're left with at the bottom is these 2's at the bottom. Now, what is that? I'm going to take it all away, and I'm going to say that is just, in fact, let me go backwards for a second. If I look at this and I want to write a simplified version of this, this is just 1 over 2 to the power of 4. And that is the new idea I want to show you, is that we can connect positive and negative powers by using this idea. So let me show you how that might work. If I say to you, you've got 2 to the power of minus 5. Okay, you can write that as 1 over 2 to the power of 5. And so I want you to just kind of see how that works for a second and see if you understand what I mean. Give me a thumbs up if that idea makes somewhat sense to you. So I'll give you another example. If I say to you 3 to the power of minus 4, if I want to change that to a positive power, it's the same as 1 over 3 to the power of 4. Okay, so this is what we call, these two definitions are ones that we use. Now, I want you to try, I'm going to give you, ignore C. I want you to try and write A and B as positive powers using this idea. Okay, so x to the power of minus 3, how could I write that as a positive power using the idea that I just discussed above? So, and look at the example in red directly above it. If you had to mimic that example.
Mr. S, we have a question from Peter.
Go ahead, Kita.
Peter, you can unmute yourself and ask your question.
Go ahead.
Okay, Peter's not there.
Okay.
Hello?
Hello?
Oh, there he is.
So I just wanted to ask. So power basically means how many times the number can be multiplied.
Yes, it does. And what I would suggest, if you're joining us for the first time today, have a look at the earlier lessons because we go through it right from the very beginning.
Okay, thanks.
Yeah. Okay, so what I want to say here is for A, we would write x to the power of minus 3 as 1 over x to the power of 3. Okay, now what about B? Who can do B? Pop it in the chat. I want to see the answers in the chat there.
Mr. S, we have a question from iPhone 2.
Okay. I think, go ahead, iPhone 2, if that is you, but I think it might be a mistake because that keeps coming up a lot, and I haven't heard a question.
Yeah.
So maybe
Okay.
for now, it's probably someone pressing the button by mistake. Yeah. All right, 4 to the power of minus 2. This can be written as 1 over 4 to the power of 2. And what's more, guys, is because we know that 4 to the power of 2 just means 1 over 4 times 4, we can also write that as 1 over 16. Okay, so we're starting to learn how to work with negative powers. Now, both of those are correct. 1 over 4 squared, 1 over 16, they're both fine. But I just wanted to point that out to you. I'm going to leave that for now. I'm going to create my own little questions now. If I say to you, so let's make this question C and question D. Can you write 3 to the power of -3 as a positive power? And can you write, let's do another one. If I give you 1/2 to the -4, can you write that as a positive power? So that's C and D. Okay. So just write down those questions. Synth, I see you said you didn't understand A. So A was x to the power of -3. So I'll talk about that while the others are working. When we deal with exponents, so exponents are these powers up here. They have their own laws and bits of mathematics that go with them. And so what I've introduced today is that if you want to go from a negative power to a positive power, all you do is you simply take it below the line. Every number can be written over a power of over 1. And so what I said in A was you bring that x to the -3 below the line and it becomes that. And so that's the idea that we're using. We're just making sure we know how to manipulate negative powers. So
I'm confused.
Mr. S, there is a question from Taslin.
go ahead, Taslim.
Taslin, you can ask your question.
How do you get your 1 by the negative? How do you get it?
Okay, go again. So which question are you referring to? A, B, C, or D? Which question are you referring to?
A.
A.
Yes.
Okay, okay, so in A, which was the question, I think it was the one that was like this. You always, any number can be written over 1. Okay, so we call it the phantom 1. There can always be a 1. In fact, there's a 1 here and a 1 here. Now, what happened in A is that when you bring it below the line, the 1 on top stays there like it's always been there. And when this comes below the line, it becomes +3. And that's kind of what's happening in C as well. If you look at C, 1 in front of this, and there's a phantom 1 on the bottom. When I move this below the line, the power goes from negative to positive. And then I've just written it as 3 to the power of 3 is just 3 times 3 times 3. So Lily, ask yourself, there's 2 parts that are involved. The one is to go from the negative to the positive power. So that's step 1. Then once it's a positive power, what does 3 to the power of 3 mean? 3 to the power of 3 means, if you think about it, 3 times 3 times 3. Now ask yourself, what is 3 times 3 times 3? It's 27. Does that help a little bit? So if you look at the first step, I want you to concentrate really is going from a negative to a positive power. And then to ask yourself, what does power mean? It just means to repeat multiplication. So it's 1/27. And then let's do D. Now D is a little bit different because what we have is the negative is at time. So what do you think is going to happen? Yeah, what's going to happen is we're going to move it to the top, right? Now, if we move it to the top, it's going to become a +4, and then there's always a 1 left behind. Now, what is 2 to the 4 the same as?
Should your answer always be 4? Should your answer always be a positive answer?
Yes, we normally try and change it until it's positive. It's not wrong to be negative, but we normally like to try and change it to be positive powers in the end. But what is 2 to the power of 4 the same as? It's 2 times 2 times 2 times 2, so that's 16. Okay, so what we're going to do now is we're going to take a little break, and then we are going to come back and practice some more of these all mixed together. So for a moment, I want you to all stand up for a second, because I know that we've been working hard and our brains do need a little break. Okay, so I want you to take a break, and I want us to just do something to let our brains wander for a little bit. And so I have these things called brain breaks that I like to do. And so I want you to get a pen, but we're going to do something a little bit different this time. So get a pen or marker. And what I want you to try and do is I want to see, can you balance a pen on your nose? Let's see. Oh, okay. And so that is my brain break for today. See if you can balance. Oh, there we go. And then if you're very good, can you move around with it on your nose? I feel like a bit like a seal at the aquarium. Sammy the seal. But I know it's silly, guys, but we're just trying to have some fun to get our brains off the topic at hand. And so see if you can balance it. Some people will be better than others. I want to see what's out there. Tato, come on, you can do it. Madisa, you can do it. Give it a chance.
Yeah. Issa says it's easy.
Is it, okay, so is this easier than the other brain breaks? Is this easier than the switching hand sling? Yeah. No. All right. So, like I've said before, I like to have new brain breaks from time to time. And so if you've got a clever idea for brain breaks, please do bring it to us, and we'll give you a chance to do it as well. And Lebo is also going to be looking for interesting brain breaks for us to do. Okay, so let's get back to the maths at hand. I'm going to now mix in a couple of different questions from this section, okay? And I want you to try and do them for me. So first of all, I'm going to give you the first 5. So I want you all to do those first 5 questions. Now, some of them are going to use stuff we've done in previous lessons. Some of them, in fact, before we do that, let's just focus on the ones that are just from today, and then I'll come back to that ones. So let's do these. I want you to do questions 6, 7, and 8. 6, 7, 8, and I'll also say 5. Do that for me now, and let's see how it goes. And then once you've done it, put that in the chat. All right. Okay, so you're right. The first one isn't too tough. The first one would just be 6 to the power of what? Yep, I see the answers coming through. Keep them coming. Six to the power of 2, yes. And you can leave it like that. You could also write that as 36 if you want, because 6 squared is just 6 times 6. Yeah, perfect. What about the next one? Okay, the next one is x to the power of -3, but now I want you to write that as a positive power. So what can you do to write that as a positive power? So you're right, it is x to the power of minus 3. But now how do I write that as a positive power using what we've learned? Yes, Michele, I see it. It's going to be 1 over x to the power of 3. Yes. Because notice how if it's a negative power and you want it to be positive, you just take it below the line. Okay, what about 7? What is 7 going to be? And what is 8 going to be? And for those who are feeling on top of things, you can go ahead and do 9 and 10 as well. And 8. So 7's answer is going to be 1. However, answer for 8 is not going to be 1, it's going to be minus 1. Because everything inside the bracket has the 0 applied to it, so it's a 1, but the negative is out in front. So that's 8 is going to be negative 1. So let's see, can we do number 9 and 10? Now, number 9 and 10 is going back to previous lessons, but let's just see, what do you guys get for number 9 and number 10? Careful, Yanda. Remember the law, what this means. Y to the power of 4 to the power of 3 means y to the power of 4 3 times. Now, this, you can do it a short way with the law, but you just need to be careful that you get the right answer. So the law would say that either you do it like this, in which case you do it the long way, and then you see the answer is y to the 12, or you know the law and it says 3 times 4, and that should be y to the 12 for number 9. Yes, well done. Okay, let's try and do 10. Today's lesson is all about mixing these things together, right? Just making sure we feel comfortable. Okay. Now it's going to take, if I write this out the long way, I'm going to have to write 4 of the things inside the bracket. But from previous lessons, what is useful to know is that there's a 1 there next to the y. It's not written, but it's there. So if you're taking this and you're applying the 4 to all of the things in the brackets, the law that you know about is that you multiply. What's that going to be? It's going to be x to the 8, y to the 4. Okay. Can you explain 10? I absolutely can. So if I look at 10, what 10 has is it has something in a bracket and then it has the 4 outside. Now, what I said was if there's no power there, there's automatically a power of 1 there. There's 2 ways you can do it. There's the long and the short way. The long way says take whatever is in the bracket and just repeat it 4 times, because that's what powers mean. This 4 over here says repeat whatever is below 4 times. If I do it that way, I can then say, well, I've got x squared, x squared, x squared, x squared. If I'm multiplying those together, I get x to the 8. And then how many y's do I have? Y to the 1 times y to the 1 times y to the 1, and I get y to the 4. Now that's the long way of doing it. The shorter way is what we call law 3, is when we multiply the power outside by the powers inside. 4 is 8. Notice how both answers are the same. Okay, so let us take that idea and do those 5 questions. So I want you to write each of these as a positive power and 17 to 23. This will be,
Mr.
I think, the long, yeah.
Sorry, Mr. Ace, there's a question from Pumzile.
Go ahead, Pumzile.
So I wanted to ask about the answer for number 10. I got my answer as x to the exponent of 8 and y to the exponent of 4. Should the answer be just like that?
Yes, that was the answer. Yeah,
Should we
that
leave
was
it
the
like
answer. I
that?
remember. Yeah.
Oh. Should the
It was
answer should
x to the 8. X to the 8, there's the answer. X to the 8, y to the 4. Yeah, perfect.
Okay.
Okay. So I want you now to write these as positive powers. And so 19 is just going to be 1 over y to the 7. Piece of cake.
Mr. Ace, I'm not sure what Tato means, but he says, when doing exponents, is it possible to divide the bases?
If you divide, no, so the bases, you only do questions where the bases are, you always work with the bases being the same. So you keep them separate and the base is the same, if that makes sense. I'll show you in another question now. So let's look at 20. 20 is going to be 1 over 7 squared. And if you like, 7 squared can be written, what's 7 times 7? It's 49. So 1 over 49. Yeah. And what's 21 going to be? It's a bit easier when it's written like 21 is. Yeah. So the negative is at the bottom. How do we make it not negative? What's the rule that we can follow? This is in the chat. Okay, so 21 is just going to be x to the power of positive 5, because when you bring this above the line, it changes to a positive.
Mr. Ace, we have a question from Punzile again.
Go, Pumzile.
So I wanted to ask, there at number 21, where you said x to the exponent of -5.
Yes.
How exactly do we find the answer? Because I'm used to saying x to the exponent 5, but -5 really confuses me.
Okay, so all you need to master is the law that says with exponents, if you have a negative power and it's in the denominator or below the line, if you move it above the line, it changes to a positive. That's the basic rule that you need to master. So, I'll give you another example. If you see that, that's the same as that. Does that help a little bit? Just that process.
Okay, I see.
Okay, so you'll see me apply this now in a moment. 1 over 2 to the -4 is the same as 2 to the power of 4, positive 4, because I've brought it above the line. And if you wrote that out in full, it would just be 16. Now, this last one is a little bit, well, this isn't as tricky because x to the power of 5 times x to the -1, their bases are the same. And so if the bases are the same, we simply add the powers. But what's 5 plus -1? It's just going to be 4. And so we get that. Okay. So that's what I was kind of showing you with the negative powers. Let's try and do these 3 more. So with negative powers. I want you to try. Yeah.
Sorry, Mr. Is, do you mind explaining number 20 again? There's some confusion in the chat.
Okay. So 20 is 7 to the power of minus 2. So while I explain 20, everyone else can get on with the next couple. So 20 was 7 to the power of minus 2. Now, first of all, the main problem is this negative power. And the way we deal with that is using a mathematical rule, and we write it as 1 over 7 to the power of 2. Okay, so now we've got that. Now, I might have caused some confusion because now it becomes 1 over 49. But that is really just about expanding what this means. And what this means is 1 over 7 times 7, because 7 squared means 7 times 7. And if you know what 7 times 7 is, it's just 1 over 49 then, like that. I hope that helps a bit.
Mr. S, there's another question from Mamelo.
Okay, Mamelo, go ahead.
So can I ask, like, at 23, like, aren't you timesing the 5 with the 1?
No, so this is what we call, so I would highly suggest looking at our earlier videos. If you're multiplying two things at the same base, you need to simply add the powers. And so that is what we're dealing with over there. I realize the time is flown by. So what I'm going to do is I'm actually going to give you the answers for these last ones quite quickly. And then Lebo, if I could ask you to please pop the quiz in the chat for the students. So they do have that link. So because it is, I see already 10 to 6, and I need to pop across to our grade 11s fairly shortly. So 24 is 1 over x to the 6. And then 25, that is going to be, look, the bases are the same, so we add the powers, so we get x squared. And then this last one, all of these bases are the same. So what we're going to do is we're going to write that base, and we're going to go minus 13 plus 4 plus 6. Now, what is that going to be? That is going to be minus 13 plus 4 is minus 9, plus 6 is minus 3. But now, how am I going to write j to the power of minus 3 as a positive? It's just going to be 1 over j to the 3.
Should we start the quiz?
Okay, yeah. So if you are, so once the quiz is, I'm just going to wait for Lebo to post it in the chat.
She did.
It's posted,
Okay.
Mr. S. Yes.
Okay. So everyone, once you are, I think that now what I'll do is that everyone can go off to do the quiz there. And then we'll take it from there. And I'll just take 1 or 2 more questions while you guys go off to do the quiz to wrap up the lesson today. So I hope, so the main goal of today was just to give you a feel for working with negative powers and the power of 0, which I think that came across reasonably clearly. Are there any remaining comments or questions?
Mr. S, there is a question about 23 and 25.
Okay, let's talk about that. Hello?
So can you see this says that she doesn't understand 23 and 25?
Okay, but does she want to come and ask a question?
Can you see that? Can you ask your question?
So for 23 and 25, so what do we do? Because I'm confused.
Okay, so in 23 and 25, they're both the same type of question. They're multiplication questions. And so the first thing you do is you check that the bases are the same. If the bases are the same, you simply write down that base. So in both those situations, the bases are the same. And so write down the base. If you're multiplying two things together and the bases are the same, you simply then add the powers together. So 5 plus minus 1 is 4, and then 9 plus minus 7 is going to give you 2. So it's because you're adding these two that get that. Okay, I hope that helps. What I'm going to do now, I'm going to pop off because I have to get to the grade 11s. Label, if you could just stay on to make sure all students have access to the quiz. And I will go from there. All right. Cheers, Label.
Okay. Bye, Mr. Ace.
Cheers.